Hello there, my name is Seth Juarez, and I'm going to talk today all about machine learning and AI and how you can use it in your business starting today. Now, here's the thing about machine learning and AI. It feels like whenever we talk about it, everyone's all like, well, you basically start here and then you end up with this thing right here, and that's not very helpful. The other thing that's interesting, and this is true story, I have a news article that you will see right now on your screen that says that 40% of AI startups in Europe have nothing to do with AI research at all. And so that's interesting. So there's a lot of misconceptions about what AI is, what machine learning is. Today we're going to talk a little bit about what it is and how you can use it starting today. So what is this stuff anyway? So when it comes to artificial intelligence, imagine artificial intelligence as this huge bubble. And I know when you say bubble in tech terms, it's bad, but just go with me here. AI is this big bubble, and it's the set of algorithms that basically make your computers feel like they're kind of human. Now the thing about it is that they're not necessarily machine learning. And that's an important distinction. Because, for example, if you want to write a program that you can play tic-tac-toe against, it's very easy to write that without machine learning. It's basically a search problem. Think of it. You have a tic-tac-toe, someone puts a 0 there, you create a list of everywhere that the other person can put the X's, then you can make another list of where if they put it there. So basically this huge tree happens and you can search it. And I can make a tic-tac-toe program without any machine learning that can always draw, or will always draw, without question. That's artificial intelligence. Also, artificial intelligence has been used many other times to make things that are seemingly intelligent, but not really. Glorified search problems are an example. For example, something that finds a path, there's a particularly good algorithm called A*. That's AI, but that's not machine learning, and that's an important distinction. So when we're talking about machine learning, that is a subset of what's inside of AI, and that's an important distinction because there are algorithms that live in AI but that are not machine learning. A good example of a machine learning algorithm is something like a decision tree. And you've probably seen a decision tree, but imagine now that the computer, instead of you creating a decision tree with if and else statements, instead it figures it out for you. That's machine learning, because machine learning is a discipline where instead of producing algorithms yourself, you give the machine data and answers, so the input and the answers, which is collectively called data, and then out flows an algorithm. Basically, you are harnessing algorithms that will produce other algorithms in serialized format, which is pretty cool. Now, it's important to distinguish between machine learning and something called deep learning, which is, again, another subset of machine learning, because deep learning has specific algorithms that live within it. For example, decision tree is a machine learning algorithm. Neural networks, depending on how deep they are, would be considered deep learning. Anything that has like a neural network-like architecture and is n layers deep, and the n we still don't know what it is. It depends on if you're marketing or engineering, of course. But that depth is what causes it to be called deep learning. And there's certain algorithms today that are like tons of layers deep, millions and millions of parameters that it's using to optimize. But again, just like machine learning, you are feeding it the input and the answers, and it will produce an algorithm in the way that it knows how, and that's deep learning. So here's a question. Because as programmers, if you're a programmer, if you're a developer or a business analyst or whatever, you kind of get this horse sense for what is it that I should be using to solve this problem. So today we're going to talk briefly a little bit about when you should use it. So imagine you work at a bank, and this is an important thing because if you're an IT person at a bank, bless you, because there's a lot of data in there, and people always put data in the wrong place, and Bill always puts name in the age field, and you're like, why are we using this database, etc. Let's talk about a particular problem. So pretend you work at a bank, and you are their crack engineer, and your name is Sally. So Sally, you're sitting there typing, and one day Steve from marketing comes down, and he's like, look, I have a really great idea for you. And anytime the marketing guy, Steve, comes down, Sally, you know that there is some work that's going to happen on your part. So Steve says, hey, look, we have an idea. We want to make it so that anytime anybody puts a check into our little check reader thing, we will automatically detect whether it's upside down or not. And so Sally is a crack engineer, and she's like, okay, Steve, tell me about these checks. And it turns out because you work at a really cheap bank, your checks have a black stripe at the top. Easy. So Sally, she gets a couple of these pictures, she looks at them, and she's like, okay, this is going to take me about a day. You tell Steve, really it's going to take about 3 hours, but we take a lot of breaks for programmers. And YouTube is not going to watch itself, and that's important. And I mean that. So imagine you tell them, take a day, in about 3 hours what you do, and you can think of this in your head because as programmers we have this programmer lizard brain that tells us how to put stuff into steps. You think, if I draw randomly from 1,000 samples at the top of the check and they're all mostly black, check is right side up, otherwise flip. So good. So you finish that, and Sally, she gets that done in 1 day. 1 day. And Steve comes back and is like, this is amazing. Good job, Sally. I was talking to the company president, Bill. And Bill was like, he really loves his French poodle, Fifi. And so he's like, you know, just this one thing, we just want to add this one more thing. And anytime marketing guy Steve comes to us, programmer types, and it's like, it's just one more thing, then we all become terrified. And he's like, hey, Sally, Bill would like to add Fifi's picture to the check. Okay, Fifi's picture to the check. And you're like, okay. And he's like, but it's just this one thing. Okay, so you muster up the energy and you say, Steve, can you give me the picture? Notice that I said the picture, because it's only allowed one. The picture that you're going to put on the check. And he goes, yes, and he brings it in, and you're like, okay. So you finally, like, you tell him this is going to take 3 days. It's going to take 1 day, but you know, we take a lot of breaks. So after you think about it and you spend a day, you basically figure out that for this picture, there's certain anchor points and there's a lot of if statements and for loops, and you make it work, but you got to go home and take a shower because you wrote that code and someone's using it right now. So notice that when we went from the black stripe at the top, it was pretty easy to figure out the series of steps that we wanted to make. When we went to the dog picture, it was a little harder, but it was still doable, okay? Because we looked at the picture and we figured it out, and we wrote an algorithm with if statements and for loops and everything else that made us take a shower. Now, you get this done in 3 days. Marketing guy Steve is so happy that everyone comes back and celebrates your awesomeness and says, Sally, we know this is super easy because you've already been able to do this all in under a week, but we want you to do this for any picture, for any check, for any customer. And I'm leaving this silence here strategically so you can feel the gap. Any picture, any customer, any check. Notice that the problem went from I can kind of do this to I have no idea how to do this. It is that gap right there where machine learning fits the best. And that's the smell that I have. The question that I have is this difficult to program on my own, number one, and number two, do we have the data or examples of data that will help us to do that? Because it turns out that with regular programming, as you know, you basically create an algorithm with some example input, and then out comes the answer. So your programming is basically you write the thing. Machine learning swaps that around. And that's important because now, instead of you creating a series of steps to solve the problem, with machine learning, you give it the answers and the input, and it will produce an algorithm. In machine learning parlance, the input is called the data, and the algorithm is called the model. And that's the important bit. That's the if you ever heard of a machine learning model, it's basically the output or the artifact of a machine learning process. And these models look different. Just like any function that you would have that you're creating as a programmer looks different, these all look different or serialized different, but they're just a little bit funnier, primarily because you did not program them, you instead trained them. But the question again becomes, how do I do that thing in the middle? And that's what we're talking about 3 ways that you can do that starting today. For example, the first way you can do it starting today, no question. The other ways get a little bit more technical, but you can also do them as well. So 3 options that you have to work on that middle question mark bit. The first is you can use models that have already been built. And you can do this today. It's pretty easy to do, in fact. There's a lot of machine learning models that have been built that solve a bunch of specific tasks. I'll give you an example. Vision, speech, language, right? If you think about like computer vision, because that's what I'm good at, looking at a picture and deciding what's inside of the picture is a difficult thing to program, but it's pretty easy to give the computer millions of images, tell it what's inside of it, and then have it produce an algorithm. And it's been done so many times that now it's basically a service. You can see the same with speech. How do we convert people speaking to speech, which is basically a sequence of like how high is the sound into a string of text. Notice that you could program it. It would be hard, but if there's a service that already does it for you, you should just use that. So let's do a little bit of a demo here with Cognitive Services to give you a sense or to show you what it's like to use it. Okay, so if you go to azure.com, you'll be able to go to AI and machine learning right directly into Cognitive Services. Now, there are the 3 or 6 that I've talked about. We've added some since. The latest one, anomaly detection. We have speech. But like I said, I am a vision guy. And notice that when it comes to computer vision, there's a number of things you can do. Same with speech, same with language, as well as anomaly detection, search, etc. But basically, these are pre-canned models that have already built for you. So I'm going to go to Cognitive Services because that's what I like. Now imagine using your own pictures, uploading them, and then getting the answer out that you want. Exactly the right answer. So here, for example, is a pizza, and notice that it has figured out that it is a pizza covered with different toppings. No challenge for it, and this is something you can use straight away. Let's try a hot dog. I don't know why I use this hot dog image, but basically they're scaring me. But basically it's a hot dog and a bun. We should retrain the AI to say not very well made. I will talk to the engineers immediately. Notice also that you can do a number of other things. Like, for example, what if your images have text and someone wants to be super sneaky and like sneak bad words on a picture? Well, you have an AI or a machine learning model pre-built that will tell you what the text is and where it is on the picture, which is quite amazing. What if someone handwrites something and you want to get that out of a picture? Well, I'm going to do a little experiment here. I'm going to write a little thing down right now because I want to see if it can actually recognize my handwriting. Now, this is for reals. I wrote this with my very own fingers. I'm going to save this here to my hard drive, and I'm going to upload it into the service. Notice that it indeed got it, which is pretty cool. Again, there's an API that you call where you upload the picture and it just happens. Here's a funny demo. I did a talk once with a famous guy, uploaded the picture and it recognized him and not me. Here's a picture of me and my lovely wife. Notice, yeah, that's right. Those engineers must have seen that talk, and so now I am also, according to this AI and my mom, I am a celebrity. I think that's pretty cool, don't you? So option number 1 is to use a model that's already been built, pre-built AI. Option number 2 that you have is you can customize pre-built AI to do whatever you want it to do. Now, here's the thing though. It has to be done within a very specific framework. So like I said, I am a vision sort of person, and so you will be able to see the demo of something called customvision.ai. I'm going to show that to you right now. I pre-recorded this, but I'm going to walk you through it because I wanted to cut out some of the boring steps. I will tell you where I cut it out, okay? So here is customvision.ai, and I'm going to go ahead and do a hot dog versus pizza to keep in line with the garbage food analogy that I am so happy about right now. So notice there's a number of different types of things that you can do with pictures, and what I'm going to do is I'm going to choose the food domain, and notice that you can also choose basic platforms. So what I'm going to do is I'm going to add a couple of tags. One is for hot dog and another is for pizza. Fantastic. And the next thing you have to do is you have to upload some images. So there are some hot dog images. I made that part go, but the upload part I did not speed up, just the picking. But to show you that I did indeed pick pictures, notice that here is the pizza part. I'm picking just a bunch of pizza images. By the way, you're probably wondering where I got these images. If you go to bing.com and search for images, you're able to pull down images. And there is a way to also select images with licenses that are amenable to this kind of thing. Now I pick the right tag, upload. There you go. Now I'm going to train it. And notice you just push the button. And it is done. You can notice that it got 100% precision recall, whatever. And now to test it, just go to browse a local file. I'm going to pick a random hot dog here. Let's go to one that actually looks tasty. That one looks good. Notice 99% that it is indeed a hot dog. Now let's choose a pizza. So let's go down here. This one. That's a nice one. Notice that it guessed, again, pizza. But that's not all. Wait. There's more. You can also download the actual model. Remember I told you that was an artifact of the actual process? Notice that when I open it, there are no magic unicorns in there, but basically a structure. That's an algorithm that it produced. And notice that when you look inside, it's basically the pictures go in the top, the answer comes out the bottom, which is basically something that you would totally understand. Now the thing about these cognitive services that I was talking about, that's what both of those were part of our cognitive services offering, whether you just use the model straight out or you tweak it a little bit, these cognitive services models, currently one of the cool things is that we are offering them in containers. As far as I know, the only cloud vendor that will lift and shift down if you need to. Imagine a scenario, let's just pretend for a second, and I'm going to just give you this business idea for free. And when you have your own huge building, I will come be your janitor. Imagine if you wanted to build a parking lot attendant that was AI-based. You have everything you need here. You need a camera. When the car comes in, you take a picture of the license plate, and if they are a member, it will automatically upload that picture, get the text out, and you're able to correlate that with your database. You're like, well, but Seth, my customers do not want me storing or moving pictures of their car up to the cloud. That's okay. If you run the OCR on the picture inside of a container on premises, you can get all of that locally, which is very powerful. Imagine a scenario where they roll up, the camera takes a picture. On your local parking lot, the cognitive service container says, this is the license plate. Right on there, you can create a record for the check-in time. And then when they come out, same thing. Pretty easy. Again, that's a free idea just for you. Just let me know when you have your huge building and I will come be your janitor. So again, option number 1, use pre-built AI. Option number 2, use AI that's been pre-built but then tweak it a little. And then option number 3, which is a little bit more complex but still doable, is you can make your own AI. And I'm going to talk briefly about what this actually looks like so you can get a sense for what it is that's going on, and then I'll just build upon that and then show you a demo and wrap it up, okay? So that's what we're going to do. So when you have this kind of setup where you want to build your own AI, notice that you have to have a number of steps. The first is you have to have some data, and you have to have a sharp question. Like, what question are you answering? If someone comes to you and say, just build an AI for that, that's like someone coming to a programmer and saying, just build a function that will magically do everything. That's not how it works. You have to have a specific input and a specific output. And once you know that, you'll be able to figure out how to use machine learning. The first thing is that you do have to have some data. The second part, and this is an important bit, is you have to experiment with the models because, like I said, the computer doesn't come up with the models. You basically give it the model shape and it figures out the parameterization of that model such that it maximizes the output, makes it so the output matches the answer the most. And so that's how it does that. Once you do that, then you come up with this model. Finally, you have to deploy this model and then off to reality. Now, because I'm a computer vision person, I want to show you a really dumb example, okay? It's a dumb example, but hopefully you'll like it because to me, it basically explains the foundations of everything deep learning-esque. Trust me, you're going to like this. Imagine you're going to build an algorithm to predict whether each of these pictures, it's a 9 square picture because it's 9 pixels, if it's darker at the top or darker at the bottom. That's what we're trying to figure out. So if you're looking at this picture, again, as a programmer, how would you solve it? I'm leaving a gap so you can think about, what would I do? Now let your programmer lizard brain take over. Again, you have these 9 pixels, and you can see them right here, right? You can see this is the answer. If it's darker at the top, it's a 1. If it's darker at the bottom, it's a 0. And then the 9 numbers represent the pixel intensities because it's grayscale. So you see that. Now, as a programmer, let your programmer lizard brain go free. And I am hearing you through the camera right now, and I'm feeling like some of you are saying, if you take the average of the top and the average of the bottom and compare them, then you would know. And I would say that's a good start. But mathematically speaking, if you divide both numbers by 3, you might as well not divide them. So you can add the top 3, add the bottom 3, and whichever one's greater, that's what you return, okay? Okay, so I know you were thinking that. What I'm going to do now is I'm going to force you to put it into a structure that looks a little bit like this. Now, you're probably looking at this and thinking, this looks complicated. It's not. The X's coming in are the intensities of the pixel, again from 0 to 255, because that's the pixel intensity. The W is a number that you choose. There's 9 of them. And what you do is for each of the pixels, you multiply them by the W, add them, and then out comes an answer. I'm forcing you to, and so I want you to make it so that the answer that comes out will give you the right answer. So what would you do? What W's would you choose? We should put like some sound underneath here so people will be like, like the thinking. Is there a thinking sound? We should use it right here. They're giving me the thinking sound. Now, when you're looking at this, think back to the previous, what we did is we added the top 3, added the bottom 3. How can we force that here? So I'm going to have to clairvoyantly get from you what you're thinking. So some of you are thinking, if you put 1s, the first 3 1s, and the rest all 0s, what that will do is it will multiply the first 3 X's by 1 and add them. And then you get the sum of the top one. But notice that when it comes out, that only tells you how intense the top is. What if you want to get how intense the bottom is? Well, what if you do the first 6 zeros and then 3 1s? That kind of does it too. But wait, one of you intrepid viewers are thinking, what if the first 3 were 1s and the last 3 were -1s? What's happening now is you're making the bottom negative by adding them all up in a negative way and then adding the top up all in a positive way, and then they fight. And whichever one is larger will come out to be either negative or positive, and if the answer is negative, you guess bottom. If the answer is positive, you guess top. It's pretty easy. Now, any questions out there that you may have, you can't ask me because this is recorded, but some of you are thinking, well then, Seth, what is that B that's just hanging out at the end doing who knows what? I will tell you. Imagine a scenario where you want to guess top even though it might not be darker than the bottom, but you want it to be within 10%. Then what you could do is you can add a positive number to bias the answer towards the top, or add a negative number to bias the answer towards the bottom. Now, the thing is that this is a very complex machine learning term that I'm going to give to you now. This, in machine learning terms, is called the bias, because it biases towards the top or the bottom. Let's test it out. So here is this 9 square pixel that we have now. We're going to feed in all the numbers. We're going to put the 1s and 0s and -1s, and notice the answer is 236, so we're going to guess top. Let's do it again with a 1 that's darker on the bottom for sure. Notice that we put all the 9 pixels in. The bias in this case is 0, because we don't want to bias it. And notice that at the bottom comes a negative number. Very good. Turns out that that W that you all just invented is a machine learning model. That's right. I want to let you drink this in because this is fairly surprising, because now you're giving it a 9 square image. that little operation where you multiply the numbers together and then add them is called the dot product. Add the bias, and if it's positive, you guess top. If it's negative, you guess bottom. Those 9 numbers, a 6 number, well, 10 if you add the bias, is a machine learning model. Now, if you want to think of this, for those that are machine learning folks, this is nearly a logistic regression algorithm. It just uses a function on the outside to squash it to between 0 and 1, which is pretty amazing, right? So you may be thinking, well, Seth, that's all good and well, and you think you're so smart, but what if I want to guess top, middle, and bottom? Well, dear friends and viewers, you just make 3 of them, right? And then, once you have these 3, then you can start adding more on top of them. And the deeper you stack these things, and the more complex you make them, these things, again, are called deep learning. Now, notice that you've gone from a series of small numbers. Imagine because if you think of a picture, for example, an image, it's basically height by width of pixels, and each pixel has 3 or 4 numbers, depending if it has an alpha channel. So basically with pictures, you can feed those into the bottoms of these things, and instead of just having 9 of them, you have n, which is the size of the picture, and then you feed those up again into another. Instead of having one output that's positive and negative, you have multiple outputs, and then you feed those up again, and those become neural networks. Convolutional neural networks, what you're looking at right now, do a lot of other things. They go through the picture and figure out how to make dumber pictures from it to learn from. It's pretty amazing. That's the basis of everything having to do with deep learning, which is pretty amazing. You're probably wondering, well, if I want to do this in the cloud, how would I do that? Well, on Azure, we have a number of amazing tooling that can help you with that. We already talked about the cognitive services pre-trained models, but if you want to use whatever you want to use, great. We don't care what you use on our cloud. Any clock cycle to us is fantastic. If you like TensorFlow, then we do too. If you like scikit-learn, that's fantastic. If you're a PyTorch person, that's great. MXNet, fantastic. If you rolled your own, you're crazy, number 1. Number 2, use it on our platform. The slower, the better. Now, and obviously I'm saying that in jest because there's specific times where you have to roll your own thing, but there's a ton of amazing frameworks that you can already use. We have additionally some services that can help you. For example, Databricks, Azure Machine Learning VMs, and then we have some powerful infrastructure to run on. I'm going to talk about something called Azure Machine Learning Service briefly. Now, the thing about running these things is when you choose a model shape, you don't know if it's going to work, and so you have to do it over and over again. You have to reparameterize, and these things are called experiments, and they're hard to share with a team. So for us, we have something called Azure Machine Learning Service, which amalgamates a bunch of services and tools that will help you work as a team of data scientists. For example, we have compute, shared compute. You will no longer have to suffer through the days where the password to your VM that has the GPUs on it is scratched somewhere in the bathroom stall. No longer, because you share compute now using the Azure Machine Learning Service workspace. You can also share experiments so that you can no longer say, much to your chagrin and delight of others, that it worked on my machine and I got fantastic results. Well, now these things run in containers with experiments, and the environment is shipped with your experiments as well, which is fantastic. You can also share your data, models, images, as well as deployments. And you're probably wondering, well, what does that look like? Well, in this video, I sped up it's probably like a 30 to 40 minute process that you're going to see. I sped it up just to a couple of minutes to give you a sense for what it looks like to actually run through a process like this. So the first thing we do as data scientists is we try stuff out. And usually that happens in Jupyter Notebook. So I'm doing the pizza versus hot dog. I'm using me some PyTorch, printing out some pictures, training a model. Looks like it's doing okay. Printing out some more pictures for prediction. Once I know it works and I want to make it work for a larger set of pictures, then I put it into a Python training file. Then I try that out. So I'm going to do it for one epoch and make sure that things are looking good. I have a bunch of food pictures in a folder. It's going to go ahead and try it on 883 samples, 20 validation, And for the first epoch, looks like numbers seem to be going down, I think. So our accuracy is 73, which is okay. 95 on the validation, which is amazing. Notice that the output of this process, like I said, is a model. And this is a model that I trained locally. It's not as good as the model that you downloaded from Custom Vision. But again, just like I said before, it's learning just a bunch of numbers. Once you do that, it's time to move it onto the cloud. So we're going to go into Azure Machine Learning Service by using our Python SDK to map to a compute environment, map to a data store that has all of our pictures. Let's take a look at that. Notice I'm using the Azure Storage Explorer, and the pictures literally just live right in there. So I'm going to map it. And then I can define an experiment, which is basically running the same thing I did before, but on the cloud. But the cool thing is that when you're running on the cloud, usually it feels like you'll lose some visibility, but not with Azure Machine Learning Service. Notice that we have a special widget in the notebook that will show you what is happening on the device in the cloud. So you'll see the time is sped up a little bit because obviously these things take a little bit of time. So notice by 2 minutes in, you're already running this inside of a container. If you're doing logging as well, you'll start to see, wow, you can see whether it's doing a good job or a bad job. So the accuracy goes up, the loss goes down. That's exactly what we want. Notice that it's done. We can see the output. We can also see the input because we logged it. And when I click on it, you can actually go into and see all of that in the cloud so that if you did this, it's shared with everybody. And that's the cool thing about Azure Machine Learning Workspace. Even the pictures that I output to make sure my sanity check was happening, you can see that's all working in there, which is great. The outputs that we're talking about, the logs, everything's in there. All right, so once it's done, then we need to put this thing into production. So to do that, we initialize the model, we load it up, and then we run it. And the thing about Azure Machine Learning Service is you can define a scoring file to do that. I'm going to test it here real quick locally to make sure that it works. And notice that if we're inferencing with pizza, it's guessing pizza. Hot dog, looks like we got it right. The next thing we're going to do is we're going to get the model that we just learned. We're going to download it, register it, and create an image. And to do that, basically you're telling it the environment, the scoring file, and that's it. Now we're creating the image, and finally we can deploy the image either to Kubernetes or Azure Container Instance, which is pretty cool. Here I think I'm doing an ACI export. And now we're going to try it. There's the scoring URL, so I'm going to get a picture of a pizza. All right, so I think that one will do. And I'm going to post that into my service. Notice that it gets pizza. Now I'm going to post a hot dog into this, and notice that indeed, let's give it a try here. Hot dog, fantastic. So now I know I went through that really fast, but basically you saw the end-to-end from idea to running it locally on notebooks, to running it locally in a file, to running it inside of the cloud, and then taking the output, which was a model file, in this case it was an Onyx file, and putting that into Azure Machine Learning Service deployment, which is pretty amazing. Now, here's the thing, I know, and this is the hard bit. I know that I basically did the thing that I said I wouldn't, but I drew the rest really fast. That's the only difference. So let's talk about model creation process to give you a sense for another thing that I think is really awesome to use. Imagine you wanted to pick, like, I don't know, how much a car should cost. I'm just spitballing here, never mind the slides. The first thing you'd have to do is you'd have to pick the features that you would want to use. The second thing you'd have to do is you'd have to pick the algorithm or model that you want to build. And then what you'd have to do is you'd have to optimize the parameters. And again, the data science process requires you to try a bunch of things. That's great. But then you need to do it again, right? And then you need to do it again. And then you need to do it again and again and again, and this takes forever. If only there was a way to do this better. And indeed there is. We have something called the Automated Machine Learning Service that will allow you, that will make it so that it runs these things almost like in a for loop, but smarter. Because what you're doing is when you submit your data, you're basically saying, try stuff. And in the background, we have built a machine learning model to look at the output of your machine learning process and recommend better algorithms and parameterizations. So basically, you are using AI to build AI. Cue the robot jokes. Just have them come at me. But if you think about it, when you're on, for example, Netflix, and you're watching something, right after it's done, it says, you would like to watch this, and you're like, I sure would. And you click on it. Now imagine that happening inside of the computer when the machine learning model finishes building and it gets its output. Our service, automated machine learning service, will say, if you like that model and those parameters, you're really going to like these ones. And you know what it says? I sure would. And it does that. The other thing that's cool about this is that the important bit about machine learning is you want to know what these models are doing. We have some model explainability features as well. Now, again, we've spent just a little bit of time talking a little bit about AI and machine learning. And to me, it's probably one of the coolest fields because you're letting the computer figure out how to create the algorithms. If you'd like to find out more, there's some links here. If you'd like to see the code that I built way too fast, you can go to github.com/Seth Juarez, go to Food AI, or ping me on Twitter using @Seth Juarez. Hopefully this was helpful and help you understand and demystify a little bit about artificial intelligence, machine learning, and deep learning. Thank you so much for watching, and hopefully we'll see you next time. Take care.